Welcome to our lesson on the integral of exponential functions. Today, we'll learn how to integrate functions involving e to the power of x, which is one of the most important functions in calculus. First, let's recall what we know about the exponential function. The exponential function e to the power of x has some special properties. Its derivative is itself, it's always positive, and it grows rapidly as x increases. Now, let's think about the integral of e to the power of x. The question is, what function, when differentiated, gives us e to the power of x? Since the derivative of e to the power of x is itself, the integral must also be e to the power of x plus a constant c. Let's verify this answer by differentiating the result. The derivative of e to the power of x plus c is just e to the power of x, since the derivative of any constant is 0. This confirms our answer. Now let's look at a more general form. The integral of e to the power of ax, where it is any constant. For example, what's the integral of e to the power of 2x or e to the power of negative x? To solve these, we need to use a key formula. The integral of e to the power of ax is equal to 1 over a times e to the power of ax plus a constant. This makes sense because if we differentiate this result using the chain rule, we get back our original function e to the power of ax. Let's verify this formula by differentiating it. If we take the derivative of 1 over a times e to the power of ax, we apply the chain rule. We'll get 1 over a times the derivative of e to the power of ax, which is a times e to the power of ax. The a's cancel out, giving us exactly e to the power of ax, which is our original function. Now, let's practice with a few examples. Example 1. Find the integral of e to the power of 2x. Using our formula, we have it equals 2, so the integral is 1/2 times e to the power of 2x plus c. Example 2. Find the integral of e to the power of negative x. Here, I equals -1. Using our formula, we get -1 times e to the power of negative x plus c. We can simplify this to negative e to the power of negative x plus c. Example 3. Find the integral of e to the power of x over 2. Here, I equals 1/2. Using our formula, we get 2 times e to the power of x over 2 plus c. Let's also look at a definite integral example. Find the definite integral of e to the power of x from x equals 0 to x equals 1. We use the formula. The integral of e to the power of x is e to the power of x plus c. Then we evaluate at the upper and lower bounds. That gives us e to the power of 1 minus e to the power of 0, which is e minus 1, approximately 1.718. Here's a summary of what we've learned today. 1. The integral of e to the power of x is itself plus a constant, e to the power of x plus c. 2. For e to the power of ax, the integral is 1 over a times e to the power of ax plus c. 3. For definite integrals, we evaluate the antiderivative at the bounds and subtract. Remember these formulas, as they're fundamental in calculus and have many applications in physics, engineering, finance, and other fields. Thank you for watching this lesson on integrating exponential functions. I hope you found it helpful, and I'll see you in the next video.